In the previous video, we learned about the connection between Riemann sums and the integral notation. And from this curve, we can use the integral notation to actually define the area under the curve between A and B as following. So it's integral from A to B, ft dt. Okay, so this is the area under the curve. The curve. Okay, and then let's say we defined it. Now we want to define another function. It's the same as area under the curve, but I don't want to specify the range. Okay, we only specify the initial range, but let's say it is it's t at in between A and B. So this is the, let's say we want to go with it. This is x. So I want to know what will be the area under the curve between A, the initial condition, to x. And then we define that as an fx. So fx, okay, that is actually the area, okay, area under the curve between A and x. So I can define that one simply as an fx, then is integral from A to x, yeah, of course that's the area to x, f t dt. So that is actually the function that defines the area under the curve from A to x. Of course, in this case, the condition must be x must be in between. So x, the condition here is x is more than A and less than B, and the function is continuous between A and B. So the fundamental theorem of calculus stating that the derivative of f, okay, as function of x, so it's df per dx. So this one then equal to this is the integral A to x f t dt. So then this is equal to the derivation of this function. I can write it as d of this function per dx equal to an fx. Okay, this is very simple notation, but it carries a big impact. What is that implication of this first principle of the first fundamental theorem of calculus? Number one, what it states is that every function of f that is continuous, so every f, okay, that is continuous has an antiderivative, and the second consequences of this one is that we find the connection between, there's a connection between the derivative that you learned in the first part of this module and the integration. So these are the two consequences, implication of the fundamental theorem of calculus. So next, let's see how it works. So when we learn about function, the normal function is always start with, for example, you're given an x, okay, and then we will have a function that define the y, and then we bring x into whatever the function to find an fx and this one equal to y. This is the normal function that we have. For example, we can have an fx. You can have an fx equal to 2x plus 1, for example. So for every x you multiply it by twice and we add 1. That's simple definition. You can also, for example, have an fx equal to x squared, let's say plus 2x plus 1. So what does that mean is that if you have an x, then you square the x plus 2 times of the x plus 1. That is your y. But we can also, for example, here have an accumulation function. Okay, given here we have a gt. Okay, I can define a new function from gt as following. So I will say, for example, an fx equal to integral from -3. I want to say, so that's the initial function until x. So basically what it says is I can define the accumulation function, so the area function of gt from 3 until x, okay, dt. Okay, what does that mean? What does that mean is, for example, if I have okay, I will make a table here. Okay, this is my x, this is my fx. What is x equal to -2 means? Yeah, that's equal to then integral from -3 until 2 gt dt equal to, we know that the integration is basically the area under the curve. So we look into 3 in this function here. So this is our initial condition. So it's from -3 to -2. Sorry, it's -2. So it's over there. So I can see the area is equal to how many rectangles? This is 1, 2, 3, 4, 5. So it's 5. Simple. So what if x equal to -1, for example? It's -1, then it's integral from -3 to -1 gt dt. Then this is equal to, you see here that, so this is the things. So basically it is 5 plus 5, that's equal to 10. And let's say what will be the fx if x equal to 0. So that's this 0 here. So it's integral from -3 to 0 gt dt, that equal to, then you get it easily, it's 15. Final example, let's say what if x equal to 2. So if x equal to 2, it's integral from -3 to 2 gt dt, that equal to the whole area until here. Okay, so we have that 15 or plus 16, 17, 18, 19, 20, 21, 22, 23. Then we know that this is 1. So it's 24.